We are back in ALEKS today working on 3.3. So one of your problems is going to be set up today for synthetic division. So if we are dividing this polynomial by x plus 3, what number do we have to put in the corner? -3. You see that right here. So we drop the 5. -3 times 5 is -15. 14 minus 15 is -1. -3 times -1 is 3. 0 plus 3 is 3. -3 times 3 is -9, which gives me 4. -3 times 4 is -12, so my remainder is 0. So it wants you to put the polynomial answer there and the remainder there. So we would just type in, we started with an x to the 4th, so this is going to be an x to the 3rd, 5x to the 3rd minus x squared plus 3x plus 4, and then the remainder up here will be 0. Easy enough? Now, another thing is going on here that we haven't talked about yet. What is the remainder? Well, it's the leftover, right? That's how much of the equation did not get divided out. But the remainder is actually the y value of the function at this point. What does that mean? Well, this is some w to the 4th equation, so it looks something like this. Oh, hold on, that's not right. -3, okay. It is some w equation. Well, what happens at x equals -3? Well, if this is a factor, that means that -3 is a 0, a root, which means the graph hits the x-axis at -3. Well, what if I try synthetic division using x plus 2? So I stick a -2 in there, and I do the division, and it doesn't work, and my remainder is 4. That means at -2, the value of the graph is 4. So if I went over here to -2, it would hit the graph at 1, 2, 3, 4. Which is kind of crazy, but that's how it works. The remainder is the y value when you plug -2 into the equation. So because that happens, mathematicians always want you to work problems like that. Sorry. So in this problem here, okay, we want to know what happens when I plug in 3. First off, look at the equation. What do you notice about the equation we're going to divide? It doesn't have an x. So can I use synthetic division here? Yes, because I'm only plugging in a single number. I'm dividing by x minus 3. So if we're dividing by a linear polynomial, then I can use synthetic division. So 3 goes in the corner. 1, -2, 0, -7. Drop the 1. 3 times 1 is 3, which gives me -1. 3 times -1 is -3, which is -3. 3 times -3. Did I mess up? Oh, this would be a +1. Okay, thank you. Yeah, that didn't seem right. +2. So what is the quotient? X squared plus x plus 3. I got that from right there. What is the remainder? 2. And what happens when I plug 3 into that function, I get the number 2. Now, the funny thing about this is, if you wanted to know what happens when you plug 3 in, don't do division. It takes way too much time. Just plug in 3. Right? But if you're already doing the division, then the remainder is also the y value of the function at 2. Okay, and then the only other questions you have are just regular division. So let's do one of those. Okay, what do you notice about that polynomial? Two things we need to worry about. It's out of order, and it doesn't have an x. Now, for synthetic division, we have to put it in order. For box division, we don't. I mean, you can, but watch when I divide this, you'll see that you don't actually have to put it in order. So negative x squared, 2x, negative 1. I don't know how many columns there are going to be. 6x to the 4th goes in the first box. What goes above that? Negative 3x squared. And then negative 3x squared times 2x is negative 6x to the 3rd. Negative 3x squared times negative 1 is 3x squared. Oh. Yeah, why wouldn't that be negative 6x squared? I don't know. So this would be a 12. And this, that would be a 6x squared. Okay, did I get it right this time? All right, I have negative 12. I want, so even though it's out of order, I just have to find the x to the 3rd term, which means I need an additional negative 8x to the 3rd. Pull out a negative x squared. 16x squared, negative 8x. Now, these three need to add up to be 15. So 6 plus 16 is 22. I need to subtract 7 to balance that out. Pull out a negative x. All right. Now, oh, geez. Is it Monday? I think it's Monday. Not a good sign. Okay. Now, those three need to add up to be 0 because there's no x term in the numerator. So negative 8 plus 14 is 6. To balance that out, we need to subtract 6. And then those two need to add up to be negative 8, which means I subtract 1. Can I pull an x squared out of negative 6x? No, which means those are my remainders. So the quotient is negative 6x squared plus 8x plus 7. And then the remainder, we always write plus negative 6x minus 1, and that's over the original divisor like that. Okay. Get working on 3.3. Good luck.